Hello everyone. So since we did not finish our examples for today, here's a video going over those examples, right? So the first example is f of x equals 2 times the quantity x plus 3 cubed minus 1. Okay, so we want to use transformations to graph the functions defined by f of x. Okay, remember that there are steps for graphing multiple transformations of functions. We will follow them and we will use this, I will refer to this table to transform. Okay, so first thing what I'm going to do, okay, before anything, is I'm just going to list off what I know. I know my h, I know my k, and I know a. Okay, so I have h, okay, remember h is right here. Remember, so it's x minus h. The horizontal translation is the non-intuitive one. I'm going to take the opposite. So I'm going to, h is negative 3. My k, okay, remember it's out here. Okay, it's outside of my x. So good rule of thumb, when the x values change, it is within that x, okay? And for when the y changes, it's outside. Okay, so in this case, k is negative 1. It's affecting my y values. My a is 2, okay? And since everything is positive, like this coefficient is positive and the coefficient of x is positive, there's no reflection. All right? Before I continue, I want to talk about the parent graph, parent function. When I take away everything, okay, when there's no numbers involved, I am left with, so since f of x is already used, I'll use p of x as parent function. My parent function is x cubed. All right? So what do I know about the table of x cubed? 1, 2, 3, 4, 5. Okay, I pick negative 2, negative 1, 0, 1, 2. Okay, so I'll get 8, 1, 0, 1, 8. That is my parent. So now what I'm going to do is I'm going to transform this, right, by using these steps. So the first thing is we want to do the horizontal translation. Horizontal translation is this one, it's the h. Remember, h for horizontal. Remember, when you shift something horizontally, it goes from, they have left to right, right? Since it's going horizontal, we are changing our x values. So my x values is going to be x plus h. X plus h in this case is x minus 3. Right? And then I have my y. Right? One thing, the reason why, so with the previous examples when we did the rigid transformations, I could add h and k to x and y all together. The reason why is because there were no more transformations. It just didn't matter which one. It didn't matter which one you did first. However, because we now have stretching and reflections, we have to do it in order. All right, so one at a time. So again, I'm going to do my y's first because that's easiest. Oops, so this is wrong. This is negative 8 and negative 1. Right, so negative 2 minus 3, so it's minus 5, minus 4, 0, sorry, g's not 0, negative 3, negative 2, and negative 1. Right, everything shifted over to the left 3. Okay, now what I'm going to do is I'm going to do horizontal and vertical stretch or shrinking. That is my a. Okay, in this case, I'm looking, so a, we told you guys there was like the a outside and a inside. They don't represent the same a, right? So we have to be really careful here. When I'm looking at this, okay, my 2 is on the outside of my x. It is not bothering it. So what does that mean? That means that my y values are changing, okay? So since my y values are changing, I'm dealing with a vertical change. Okay, my y values are changing. Y value represents the vertical. So is it, and for this case, is it shrinking or stretching? Stretching. So for vertical, so for the stuff attached to the y, it's the intuitive one. So when it's bigger, it's stretching, and when it is a fraction, it shrinks. So in this case, since it's bigger, this is a vertical stretch. Right? So in this case, what am I doing to change my graph? Okay, since it's a vertical stretch, it changes my y values. So my x is going to stay the same. And remember, for a vertical stretch or shrink, it's the intuitive one. It is the one where you just take your a and you multiply it by y. So this one will be 2y. So it's -4, -5, -4, -3, -2, -1. And then my y, I'm going to just double it. So this is -16, -2, 0, 2, and 16. Right? So there is no reflection. Since there's no reflection, we don't have to do anything with that. But now what we have to do is we have to do k equals to -1. K represents the vertical translation. Vertical translations change our y values. So x, y. All right, let me bring this down. Okay, so again, so this is y minus 1. It is y plus k. K is -1. Okay, so again, I have to get my x's. Right, and then now all my y, so it's y minus 1. So this would be -17, -3, -1, 1, and 15. Okay, and this is my not n of x, this is my f of x. Okay, these are my points. So let's graph it. So I have -5, -17, so that's really, really low, so I'm not even going to bother. I have -4, -3, -3, -1, -2, positive, -2, sorry, negative, -2, 1, -1, 15. Again, it's, so, man, the snakes are gone. That's fine. We'll just guess. So 15, let's say, is like up here, and -17, let's say, is like way down here. Okay, so it's a very, as we said, this is a vertical stretch, right? So it's going to be very, can't even tell. Like, it's harder to tell that this is a snake figure. And I did forget to mention, because it's x cubed, my general shape of graph would be like this. Right? So this is the graph you get. As I was looking at H and G, I didn't really like it because I realized we never talk about reflections across the x-axis or the y-axis, and we also don't talk about when, like, there's a coefficient in the x. So I changed it a little bit. Also, I want to change the ruling size. Okay, make it a little smaller. Okay, so again, I'm still going to list everything off what I know. Okay, I know that there is so I'm looking at inside here. Okay, I know there is a horizontal change. My horizontal change is -3. My vertical change, again, so that's k, it is -1. Okay, and my a is 2. Okay, so remember, the a is always positive. It's greater than 0. So what is this negative? Since the negative, it's inside my x. Okay, inside my f of x. That means it is a reflection. Reflection across. If I can spell across y axis. Okay, that's what that negative means. All right, there's nothing else that I know, so let's continue. Well, I guess that's a lie. There's more that we know. When I look at this, what is my parent function? I'm going to call it by f of x again. My parent function in this case is the square root of x. Okay, so what does it look like? It's going to look something like this. Okay, so now let's continue. So now that we know the parent function, we know the parent table. So let's go x, y again. 1, 2, 3, 4, 5. So remember, we can't pick -2 because it's not in the domain. We have to pick the leftmost point. We do that by taking the radicand, okay, the thing that's under the radical, and set it greater than or equal to 0. We solve for x. Luckily, x is already solved for us, and that's the leftmost point. So we get 0. And then now we want to pick the perfect squares. I'm just going to pick 1, 4, and 9 because we won't be able to graph 16. All right. And then y is 0, 1, 2, and 3. Okay. So now what we're going to do is we're going to follow the steps over here. So first of all, we want to do the horizontal translation. And if you want, what you could do is you could write this part to the very last. You can actually put it in order. So you say h is -3. Then you can talk about your reflections, or you can talk about your stretches or shrinkings. And we have the reflection, and then you can put the k equals -1. Okay, if you want to go in order. Okay, so because it's the horizontal translation, it's affecting my x, so I'm going to do x plus h, which is x minus 3. And then my y, it doesn't change. This is -3, -2, 1, and 6. And then my y stays the same. Okay, now we're going to do the horizontal and vertical stretching or shrinking. So remember, so A is 2. Doesn't really, like, we can't just say A and automatically know if it's horizontal or vertical because A is A. So what we're going to do is we're going to look. So remember, for the vertical, it's A times f of x. A horizontal is when f of A times x. Okay, as you can see, this 2 right here is attached to this x. So this, in this kind of case, we have a f, or y is equal to f times 2x. Okay, so this is a horizontal. Another way to think about it, because it's attached to my 2, it's affecting my x values. When I affect my x values, okay, that means it's affecting the horizontal part of my graph. So now we have to know, is this a horizontal or vertical shrink? And honestly, I apologize. I should probably not really good habit to always put A. And the reason why is because, so vertical stretch, we can say it's A, right? But for a graph, actually, never mind. No, I can still say it's A. All right. So since this is 2, okay, what I can do, so this is A, right? So remember, x, it is x over A. Okay, so this is x over 2, or you can say 1/2 x. Okay, and then y. So I have 0, 1, 2, 3, and then for my x, I'm just going to divide it by 2 or multiply it by 1/2, so I get -3/2, -1, 1/2, and 3. Okay. Now, I want to reflect this across the y-axis. Remember, since you want to reflect it across the y-axis, that means the y values will stay the same. The y values stay, they're constant, okay? They're fixed. So when I reflect across the y-axis, it means I'm changing my x values. So I'm just going to do -x. Oops. And y. Oh, dang it. Ugh, too close to the thing. Okay, so -x, so this is going to be 3/2, +1, -1/2, and -3, and my y stays the same. Okay, last but not least, what I want to do is we want to do the vertical translation. The vertical translation is -1. Okay, so what does that mean? It's the vertical affects my y-axis, so it's just going to be y minus 1. So this is 3 halves, 1, negative 1 half, negative 3. Right, and then this is going to be negative 1, 0, 1, 2. Right, and let's graph. Okay, so I have 3 halves and negative 1, so 3 halves is 1.5. So I have 1.5 and go to negative 1. Then I have 1, 0, then negative 1 half, 1, and then negative 3, 2. Okay, and this is what my graph looks like. Okay, this is what our f of x looks like using transformations. Lastly, again, I did not like the function I picked, so I did a new one. Okay, and then we're going to do this last example later. So I have g of x is equal to negative 3 times the absolute value of negative 1 half x minus 2 plus 4. So as you can see, there is a lot going on here, but it's fine. We can still do it. So again, list what we know. So horizontal is the stuff inside it. So my horizontal this time is positive 2 because I have this minus. So remember, it's not intuitive. Do the opposite. Okay, we want to do, okay, I can also write it this way. We have a difference here is that we have a horizontal and a vertical stretch here. So remember, horizontal is what affects my my x's. Okay, so in this case, so I'll call this A1. Okay, this is 1 half. The reason, so remember, it has to be positive, so ignore this negative. Okay, this is going to be my horizontal. And then because it's 1 half, remember, this is going to be the stretch. Oh, I didn't even talk about this. This one is remember, when it's greater than, it's going to be shrinking. Okay, and then my A2 is 3. Okay, and then notice it is outside the absolute values. It is outside of x. It is, yeah, so it's on the outside. It's not bothering my f of x. So, yeah, so this is also a vertical stretch. Okay. The third one I want to worry about is my reflections. It's going to reflect across the x-axis and, okay, maybe I should do this number just to really emphasize it, y-axis. Okay, there's a negative right here and there's a negative right here, so therefore we got to reflect for both. And then fourth, we have a vertical translation, and that is k, which is equal to 4. Honestly, before all this, we should talk about f of x. Okay, I've been making that habit of finding it afterwards. Maybe it'll be more helpful for you guys if you found it first. Okay, so f of x, taking out everything, the most basic one is the absolute value of x. So it looks like a v. All right, and then maybe it'll be more clear. Okay, so since f of x equals the absolute value of x, that's why this 3, okay, it'd be 3 times absolute value of x. Okay, and then this 1 half, it'd be 1 half x. Okay. So now that we know this, we know the parent function, let's go ahead and find the points and then graph. So first things first, we're going to do the horizontal translation. Remember, that affects your x, so it's going to be x plus 2, or getting ahead of myself here, should actually do the parent. 1, 2, 3, 4. Oh, there is 5 g's. Okay, so absolute value of x is just negative 2, negative 1, 0, 1, 2, and you'll get 2, 1, 0, 1, 2. Okay, so then I have x plus 2 and y. So then this is 0, 1, 2, 3, and 4. Y stays the same. Okay, so now I have a horizontal stretch and a vertical stretch. So I can actually do this at the same time. Okay, so remember for a horizontal stretch, it is our x values, right? It's changing our x values, so it is going to be x over a. Okay, so this is going to be 2x. Okay, we have x over 1/2, so 2x. Remember, multiply by the reciprocal. All right, and then for my y, it is intuitive, so this is just 3y. Okay, so this is going to be 0, 2, 4, 6, 8. And then this one is going to be 6, 3, 0, 3, 6. All right? So now we want to reflect across the x-axis and the y-axis. So what does that mean? That means both of our x's and our y's will be, so we have negative x and then the negative y. So this would be 0, negative 2, negative 4, negative 6, negative 8. And then negative 6, negative 3, 0, negative 3, negative 6. And then lastly, we have k equals 4. K represents the vertical change, the vertical translation. Okay, and it affects our y, so this is y plus 4. So I have 0, negative 2, negative 4, negative 6, negative 8. And then my y plus 4, okay, so this is negative 2, 1, 4, 1, and negative 2. Okay, let's grab a graph. Okay, and let's plot our points. So I have 0, negative 2, negative 2, 1, negative 4, 4, negative 6, 1, negative 8, negative 2. Okay, I know this is a V shape, so I'm gonna take this, make my life easier. Guess it's gonna be purple, that's fine. Okay, and this is our translated graph. Okay, so this is our g of x. Okay, so what you do essentially, we'll see how this goes. Okay, so essentially what I did, okay, let's see here. Okay, let me grab a different graph real fast. Okay, so essentially what you do here is you take this graph, okay, what I first did is I first moved it over 2, okay, like this, and then I did a horizontal stretch and a vertical stretch, right, so I distorted the shape a little bit, oops, okay, honestly don't really know. Like, for example, oh, geez. I don't know, like, you could have made it, I'll just pretend, okay? I just kind of want to talk about this in particular. And then what we did is, how do you flip it? Okay, and then what we did is we flipped it vertically. Okay, when you do that, it goes like this. And then we flipped it horizontally. And when you do that, it's like right here. Okay, and then lastly, what you do, oh my gosh, if I can grab the graph properly. Geez, sorry guys. Okay, this needs to go away. Right, and then after all that, then what I'm doing is I'm going up 4. So 1, 2, 3, 4. Okay. So about the same. The only difference is yeah, with these values, with the horizontal. I just didn't show you about the horizontal shrinking and stretching. Okay, but that's essentially what we did. So lastly, what I want to talk about is I want to go over another example given a parent function and then given instructions on what to do. Okay, this time I'll really use this table to explain, try to explain better on what we're doing. So we're given so more formally it's y is equal to x cubed. Okay, and we want to find a function that has all of these shifts. So first thing, it says shift 8 units to the right. So the first thing, when you have a horizontal shift, remember it's represented by f of x minus h. Okay, and we have to think about that. We have to think about the wording. When we have shift 8 units to the right, okay, when we're going this way, we're going more positive, right? So then h, our h is 8. Okay, it is positive 8. So then we have f of x minus 8. Okay, so then when I do that, if I represent this as f of x, okay, then this becomes x minus 8 cubed. All right. So our second one is we want is our shrunk horizontally by a factor of 1/3. Okay. So remember when you with this for a horizontal stretch or shrink, it is a factor of, and it says 1/a. Right. So when we say that, so shrunk horizontally, it's represented by y is equal to f of a times x, right? In this case, we know 1/a is equal to 1/3. When you solve it, you'll get a is equal to 3. Okay, so we get, this is f of 3x. Okay, so this, don't write, so I'm going to put it in different colors. This is our new f of x. Okay. So just parentheses, you don't have to write that down, but just use this as a reference point when we do the 3x. Okay, so when I'm doing that, I'm taking this f of x equals x minus 8 cubed, and wherever I see the x, I'm going to plug in that 3 cubed, or sorry, 3x. So, how should I, so f of 3x, then this is going to be 3x minus 8 cubed. Okay. I want to reflect across the y-axis. What do you do when you reflect across the y-axis? It is y is equal to f of negative x. Again, okay, in quotation marks, this is represents my new f of x. Okay. So then, when I have an f of negative x, wherever I see that x, I'm going to plug in a negative x. So this is 3 times, and then negative x minus 8 cubed. But I can simplify this. Okay, this is going to be negative 3x minus 8 cubed. Right, and again, this is quote-unquote my new f of x. Right. Lastly, we want to shift upward 5 units. So shifting up or down, okay, it's a vertical translation. It is affecting my y values. Okay, so we're talking about k here, and it is represent y is equal to f of x plus k. In our case, k is equal to 5. So we want to find f of x plus 5. And all I'm going to do is I'm going to take that f of x, negative 3x minus 8 cubed, and I'm just going to add 5. Okay, so my final answer, okay, we have f of x is equal to negative 3x minus 8 cubed plus 5. And this is the one that corresponds to all of the translations above. Okay, so just really take notice here, like I really suggest just looking at this and just absorbing it, okay, just kind of, and actually apply the examples yourself. But one thing, if you notice, like any patterns, if you, like, just notice like the verticals, okay, all the ones that represent, that have anything to do with changing your y value, okay, it is outside. It is f of x times something or f of x plus something. But when I am changing my x values, okay, notice it is within f of x. Okay, this is f of x minus h or f of x plus h when you're horizontally shifting. When you're horizontally shrinking, you're multiplying that f of a times x. And then when you reflect, it is f of negative x. But yeah, for the y values, it is negative 1 times f of x. It is, for vertical stretch or shrink, is a times f of x. And for vertical translation is f of x plus or minus k. Okay, everything is done outside. It is affecting your y. But to affect your x, it has to be within that f of x.